to answer them. Today we will be talking about Super T Girder Bridge, how to model, analyze, and design this using MIDASIT. You will find attachments in the attachment tab of the webinar. You can use it as a reference as we go with the discussion. In other developed countries, as New Zealand and Australia, Super T has become the preferred section for bridge spans 18 to 35 meters. So this is because they are avoiding girders with closed voids due to casting issue related to accuracy of void formers. And also, they have a difficulty of verifying clean and compact. Here are the current Australian practice. So, as you can see, for spans 18 to 35 meters, they are using Super T and tier of use. So in AS, they have various modifications of Super T girder bridges, Super T girders. So the varying depths from 70 mm up to 1,800 mm with the following span. So for 1,500 mm, for example, the span bridges would be 30 to 35 meters. All throughout this discussion, we would be referring to AS 500 year 2017. So we will be mostly referring to AS 5100.2 and AS 500.5, referring to the loads and of the concrete design. So here are the data that is available to us. We have two-span bridge with 32, 35, and 32 meter spans. And then we also know that of the columns. So for today, we will be modeling the two interior columns or interior piers. And then for section, we have six Super T girders. And we also have Lucas concrete barrier. Here is the dimension that corresponds to the moving load beam, the shoulder, and the location of the precast barriers. It's essential to know this information before moving forward with the modeling so that we can provide enough information for them to conduct its analysis. Here are the material properties that we will be using for our model. So for the girder, grade 50 concrete, and for slab and the substructure, we'll be using grade 40. Then we would be using the function found in AS 5100 for concrete design of Australian or cripple shrinking as well as for compresses. And then our pre-stressing steel or tendons, we will be using the stand from AS or New Zealand Standard 4671 with 18 with 1,800 minimum, and then we'll have a yield strength of 1,509 MPa. Strand diameter you will use is 12.7 meters, and having or pre-stressing force 1,196 MPa. So here are the tables that can be found in the Australian standard for concrete, the crippling shrinkage, as well as the compressive strength, the properties of tendons according to ES 5100. So we will be using the one ordinary strand 12.7 with 1,870 MPa minimum breaking according to AS 700. So I will be starting modeling from scratch, but later on would get some information from a predefined model. So the new model. So in the properties tab, you can find here the material properties that is based on AS5100. So first for the concrete, tendons, for the tendon, the part, the AS new standard 40. We'll be using P4, the one with depth of 1 meter. So let's get the one with P4 and click on OK. So to the parameters for design. So we need to define or the thickness of the top flange it will use. So in this case, it would be here. And you need to also define to the thickness of the bottom flange, the width, and then the effective height. For the thickness, the top flange, let's specify mm. And then thickness of the bottom flange, 260 mm. The width, 0.58. And then for the effective height, 1.3333 meters. Then for the thickness of one, we need to input the thickness of our web here, 120. And then for definition of Z1, Z2, and then Z3, we'll need to define it. For Z1, it is the termination of the top flange and the web. Then for Z2, it's centered, so it is automatic. And is the termination of the bottom and the web. Then for other section proper, you can just click on auto for it to auto calculate and click on apply. Then after this, we also define a closed super section. So we can define by using the define coordinates. So define coordinates, you can change it by changing the coordinates of x and y. Then you can also change it by deleting some of the points. So now we'll be deleting point 11 up to point 19. So if you delete those, you will have a closed super E section. So click on OK. Let's name it into close E and click on OK. So now we have data for T4 and then the closed T4 section for this PSC. So another one, then go to the composite tab. In this case, we'll need to find composite PSC since T4 and closed T4 is defined on the PSC tab. So for B, we need to define the slab width, then thickness of the slab should be 0.18. So 180 mm. It is also stated in AS 5100 regarding the slab thickness and the slab width. Then we will be importing the PLC sections that we have defined. So we have P4. We will need to select the material for the slab and the girder. So this is for the composite section to be analyzed as composite and non-composite. So let's get it from A17 database for slab C40, then A17 as well for the girder C50. And click on OK, and then the modular ratio would be automatically computed. And let's change the offset into center top. Okay, then don't forget the name of the section. So this is composite P4, apply. Then we do the same for the closed section of P4. So close composite for P4. And click on apply. Then the other section properties like the column, tier tab, and the diaphragm will be modifying here in the data user tab. So first the column, let's define the column. So, sorry. So we need to have solid round and then the diameter of the column, click on right, is under. Then let's also define the tier cap or the coping beam. So coping beam is a rectangle, also in user format, user defined. Let's change this to center top, click on OK, right? And then for the diaphragm as well. So solid rectangle again. And diaphragm. So 1 meter by 0.6. And okay. So now that we have material and section properties, the other properties that we need to define are the time-dependent properties we added for the ES 5100.5 or the concrete design for the Australian code. So let's click on the creep and shrinkage for us to make a function. Let's click on add. Then on code, let's just for the ES 5100 here. ES 500.5 2017. So yeah, let's not forget to save our models. So let's save it as model 1. So the basic data that we need for modifying the time-dependent properties for our concrete materials would be the composite strength of concrete at the age of 28 days. So for C50, we have 50 MPa. Then we need to also define the exposure environment. So as now, since this is based on the Australian standard, we only have four classifications: arid, interior, temperate, inland, and then top tropical or near coastal. So since this is based on the engineer's decision depending on the location of the bridge, can define arid or tropical, or if it will be in the Philippines. For the hypothetical thickness, we have here the formula. So we can input here one first because this will be automatically computed after that time dependent factors are inputted. And then for the drying basic shrinkage strain, it's only limited to 3 as of now, Sydney, Melbourne, and then let's just put elsewhere. And then the age of concrete at the beginning of shrinkage would be 3 days. So here's the graph, which is also the same with the graph that can be found in the AS. So this is the graph and we'll do the same for the C40. And after that, material properties, time-dependent properties, and then section properties. You also need to have the 10 properties if you want move on with the wizard. So using wizard later on. For the it's under the tab under temp pre-stress loads, then we could define that tendon property here. So tendon property then is add one. Let's make our tendons with one tendon property at first. Then this would be free tension. So property girders are pre-stress pre-tension girders. Then formula we'll use 1870 as 10. So again, strand of 12.7 mm and the number of strands, let's make it 3. And then strand diameter is automatically computed here. Then for the relaxation coefficient, if it's according to AS 100, you need to input a RB. So for RB, under AS 100 is the formula. So it's the basic relaxation of the 10 after 1,000 hours at 20 degrees Celsius. So after we compute it or after we get it from the AS and NCC 4672.1, we can input the value here. So I'll be inputting 5%. And then I kept the default values of the characteristic value of strength, the yield strength. Then click on OK. Then close. After we have defined all the properties that we need, met properties, time-dependent properties, section properties, and the properties, we can now proceed with the modeling of our structure. So there are different ways on how to model your structure. First, you can model it using the wizard, the pre-stress composite bridge wizard. You can also model it by importing the IDF file into your models, and you can also model it using the modeling functions of Midas you will found in the Node and Elements app. For us, the easiest way would be to model it using the structure wizard, the pre-stress composite bridge wizard. So the pre-stress or the pre or post-tension composite bridge wizard has 5 tabs for layout, section, tendon, load, and then the construction stage. So in using your Girder bridge wizards, you can open a predefined file and you can also save your created wizard files as a reference for future use. So we can define here in the layout tab the girder type. So we have two girder type, precast girder type and splice girder type. So precast girder type, this is where girders are fabricated offsite and are erected span by span. while the splice girder type girder is fabricated in multiple pieces and then are connected at the splice locations. So for now, we'll be using precast girder type since there'll be a straight bridge. Then you can use different modeling types. So we have three here: all frame, deck as plate, girder as frame, and then all frame, non-composite. So the first option of all frame, this one considers the composite action of the bridge. Then all frame, non-composite, considers the different parts of the bridge as separate from one another. So we will be using all frame so that the slab and the girder will help in resisting the loads on top of it. And then for the span information, just give 32, 35, and then 32. And then for the deck, so input 7.6. Then layout of set is 0, as well as the support skew angle would be 0 since this will be a straight bridge. And then for the spacing of A, input 50. So this will be the gap between the two girders when non-compass action of the girder are being considered. And for the spacing B, 0.25 is the gap between the support and the edge of the girder. And in the latest version, you have the option to check it either as continuous or non-continuous. Then if your bridge has some ridges or circular in layout form, you can check on the radius and then input the curve data or coordinate data of your bridge here. Then you can also input the substructure data of your bridge here. So let's check on the with substructure. Then here's the guide. So for the abutment, you can choose if the support is fixed elastic link or the same as pier. So we'll be having the abutment as fixed. And then for the pier, let's use the elastic link. Then for the x direction, for the stiffness x direction, let's input 1.5 kilonewton per meter raised to 6. And then for the ky, stiffness in y direction 3000. And the stiffness in z direction 3000 as well. Then the elastic length, let's reduce it to 2.3 meters. Then for the material of the pier, let's input C40 for the substructure, then the section of the pier cap, the one we defined before. Then let's set the pier same with the deck. And then for the column, then the height of the column, set this as 9. But if you want to define different column heights for every pier, check on advanced and then modify your height here. So if you input spacing, it will automatically change the arrangement of your columns accordingly. So if you put one spacing, it will input two columns. So again, here are the data for the layout tab. Then next for the section tab, let's input the deck thickness. So 180.18 material for the deck or the slab C40, girder 50, and then the diaphragm as well as C50. And then input the number of girders. So here is how the syntax of the wizard goes on. So from the from the reference line, going to the left is going to the right is positive, then going to the left is negative. Input here, negative 7.4. Negative 1.48. 1.48. then 7.4. And then if you haven't yet defined the diaphragm section, you can define it by clicking the define diaphragm section button. And then you can click on advance if you want to um, delete or not include the end support or peer support or the intermediate diaphragm. So I will not be including the end supports. And then here are the numbers of intermediate diaphragm per span. The space for the transverse deck element, I will set it as 1 meter. And then for the girder information for each tab, so let's input the division so we can add the closed tab. So for 0 to 2.0 to 2 meters, let's input the uh, closed super T. And then for from 2 meters up to 31.925, let's input and then for the second span, let's set as super T girders with the closed section. And then for the third span, let's also apply the same, just like the second one. So apply. And then from 0 up to, so for 29.95, set it as the super T with the void. And then for the last years, that is as the partition. Then let's uncheck this one since we already have the transverse deck element per 1 meter. So let's now proceed to the next tab, which is the tendon tab. So if you click on the guide for the tendon tab, you can see here the different shapes for multiple span girder types. First, we have the harp one. So here are tendons on the mm, on the elevation view of your bridge, then for the two, and then for the curve. So the curve shape is parabolic. So since we will be only using the straight straight shape, so here's the straight shape, the red drawings. Now we have a auto generation function for the tendon template, which type 4 of Super T, which we have used. So all you need to do in order to automatically generate the tendons for the Super T with 1.5 meter depth, just click on the auto generation button, then select the tendon property, use ASS code, and then choose T4, then check on the initialize tendon template, and then click on OK. Then it will automatically input these tendons in your table. And afterwards, you'll need to define the grouting for each tendon. But for me, since I have the bonding data for the tendons, I I defined it in the detailed section for the tendon. So if you click on detailed, you can see here that it has a name for every tendon. So for T1 on the first row, here are the tendons on T1, and then the number. So 1, 2, 3, 4, 5, and then 6. The reason that you cannot see the other tendons is because the bonding length. So here's the data for the bond length of your bridge. As you can see for the first row, row A, we have to the bond length on 1 meter. So this is in mm. And then for the second row, we have to the bond length at 1 meter for the fourth and for the ninth tendons. And for the row C or the middle one, we have the bond length on at 1.8 meters, 2 meters, and then 2.56 meters at the third, fourth, and fifth tendons, as well as on the other side. And then for the fourth row, we have the bond length of 2 and 2.4 meters for the fourth and fifth tendons. So let's see how it is reflected in the detailed input for the tendon layout. So as you can see, P1 is at the bottom. So we have 8 tendons there with the first and the last that has the bonding. And then for the second row, we have the bonding on the fourth tendon as well as on the ninth tendon. And for the third row, we have the bonding on the third, fourth, and the fifth tendon, as well as eighth, ninth, and tenth tendons. So we put the bonding length here for every tendon, and then we put the jacking stress for each of the tendon here. So what you actually see here in the drawing is the extreme extreme member of the span one. So if you click on span 2, you can see here the tendons that are being pre-stressed on the second span and for the third span as well. So these are all first members, first elements of every span. So the next tab would be the load tab. So on the load tab, we have to define the distance for the barrier, the roadway width, and then the width of the median, as well as the other roadway width and the other sides barrier. So if you don't have median, just like what we have in our model, in our data, you can input 0 there. And then as for the others, dimensions are indicated in the modeling statement given to you. So we have an option here if you want to divide the loads equally to all girder for DC before the composite and then DC after the composite. So I chose to divide it equally to all girder before the composite so that all the girders will have load. And then for the DC after composite, decided that it should be on the specific girder only. So I did not check it. Then for the other loads value, so for self-weight, we only need to check it. So it is by default on the direction. And then for the weight of the wet concrete, we need to define the weight density and the thickness that should be loaded. So it should be 0.18. And then if you have formworks, you can also define the value of the loads here. And for median, we have median, so let's keep it checked. But we don't have, I mean, we have barrier, so we need to keep it checked. But for median strip, we don't have median there, so we need to uncheck it. And then for the wearing surface, here are the values of the weight density and the thickness of the wearing face. And for the moving load keys, in order to activate the live loads, we first define the moving load keys. So check for the moving load code of Australia. Click on OK. Then check on the live loads. Find the traffic line lanes. So the traffic lanes are in the center of every wheel of the vehicle. So for the lane 1, the distance from the edge is 3.63. For the lane 2, the center of lane 2 is on 7.13. Lane 3 is 10.63. Then D4 is 14.13. And for the vehicles, we also need to define it according AS 5100.2 for the loop. So we have standard for that. That is divided into road traffic, pedestrian, rail traffic, heavy loaders, and then for rating vehicles. We will be using the road traffic. So we'll be using M1600. So M1600 for the moving load traffic has a dynamic allowance of 3%. Here's the load traffic M1600, and here are the values that are stated in AS 100.2. We'll also be applying the stationary traffic load or S1600. Let's go back to the M1600. And then S1600. Then S1600 doesn't have dynamic load allowance. It's not moving. So click on OK. If you already defined the two vehicles, close this one. And then after that, we're done with the load tab. Let's go to the construction stage tab. Construction stage is being shown here has up to 8 construction stages. So whichever is applicable for our model, it automatically, for example, CS1, where it directs the substructure and install work, false work for any. So we have that substructure, and then the girder part. So our composite girder is divided into two parts, the girder and the slab part. So in CS, girder parts are activated. And then for CS3-1, we have deck that is being considered CS or construction stage 3-2. This is where the decks are considered as structural elements. And then for the fourth construction stage, after composite loads are activated already, like the bearing surfaces and the moving loads. And for the fifth construction stage, long-term effect is considered. So this is where time-dependent effect is being act onto our structure. So you can change the duration of each if you have tried it already. So after you fill out all of the details that are needed in the bridge wizard, you can save it. So you can save it and use it again for other projects, or if you have some revisions on your previous. Then click on OK. Now that our model is completed by the bridge wizard, we can now inspect all the things that it has automatically generated. So you can see that on the end of the gear doesn't have diaphragms. We unchecked it on the section tab, but it have uh, for the interior diaphragms. And then it already inputted two composite section for construction stage, the closed super T and the super T section. Then we can now inspect each of the construction stage that it automatically generated. So, for example, for the stage one, generated the substructure. Stage two, it activated the girders. Stage 3-1, we already have then wet concrete code. And for the stage 3 slabs are already activated. And then for the stage 4, the barrier and the wear phase are activated as well. And for the stage 5, this is where the time-dependent materials are being acted on. So we can only make changes on the base stage of our model. So we need to just um, modify some of the some of the properties. Say, for example, the material length of C50 and then C40. So in order for us to um, attribute the compressive strength, creep, and shrinkage to C50, we can use the material link here. C50 and then which material for C as well. And then add. Now it is already assigned. Then the next will be modify the load. So moving loads can be found in the load tab. So under load tab, moving load, then moving load cases. So let's add the moving load test. So the program just ought to see our. So going back, moving loads, and then it could identify this a load case for permit vehicle, or if you use moving load optimization. But use Girder Bridge Wizard, not optimize. So it can also modify its general load model, fatigue load model, heavy load platform model, or real traffic load model. So the combination for different moving loads will be different. So just identify it as general. And then here are the data for the accompanying lane factors. So these are also based on AS 100.2. So we need to define the subload cases. This is where we will combine the lanes and the vehicles together. So there are two loading effects combined independent. First, if you choose the independent, it will apply first the load before it gets the result. But if you choose to have the loading is combined, it will first combine the loads together and then give you some give you the result based on that combined forces. You will could use the combine and add. So first for the M1600, we have four lanes, maximum number, and click on OK. Then we would do the same with the load, stationary moving loads. Then click on OK. So now that the moving loads are already assigned, we can modify our composite sections for construction. So as you can see here, we have two composite sections, the Super T 1500 depth and the Super T. So first we will modify the Super T. So we need to age. So I set it at 7 days for the first part, which is the girder. And then for the second part, the slab, 10 days. So let's just input first a value for age. Same thing with the closed super T. So this will um, this will avoid convergence errors or convergence warnings due to construction staging. Because if you did not define the age of your structures correctly, it can affect your model. So the strength of the year not be attained accordingly. So we hit all so it is successfully completed. Can see now that the age are updated. So we need also to modify the age of our structure in the construction staging. So it's on stage 2. So modify, and then is where we will define it. So for the girder, so on the stage 7 activated already, click on OK, close. Then aside from that, you can also input the reinforcement so that we can use it for the design part. So for reinforcement, it is the properties tab, reinforcement. Then for composite T4, can have a guide so we can easily draw our reinforcements. So I'll be using input method B or using the coordinates. So I'll start from the guidelines, the end, then input the number of the rebars, check on the error, and then change. Let's change the sizes here. So let me close the first, then go to the tools tab, then modify the preferences for the sizes of the rebars. Then go to the design or load code under preferences, and then choose AS17. Ano? Let's again to the section manager reinforcement. And then for the composite for do it again. Then the number inch bar and say 16 mm. Then part 1 is the girder, part 2 is the slab. So it's should be on part 2. And click on apply. Then let's do the same for the shear reinforcement. So let's just input diagonal reinforcement. So for diagonal reinforcement, let's input pitch as 150 mm or 0.50, then angle 90. Then input a number of reinforcement for every meter. And for torsional effects, let's input the same data. If you have preliminary design for this, you can also do that. But this is optional. You can just check your model first and then get the recommended area of steel and then input it afterward. So after define the data for D4, so we can copy these reinforcements to both of the other composite sections. So close this one. Now, after we define everything, there are others tutorial like the thermal effects as well as the earthquake tools. So maybe we can include it in some other time. So I will be running the analysis for this model. So let's go to the analysis tab and then click on perform analysis. So the runtime of the analysis is purely dependent on the complexity of your model as well as the specifications of hardware that you are using. Also, if there are other applications or open with with MIDASIT. So let's wait after this analysis performed. We have finally finished the analysis for this model. So as you can see, analysis is conducted after 850 seconds. Now, when we go to the results tab, you can see the load combination function can click on combination, and then let's make use of the auto generation button. And for the code section, use a concrete section, and then look for the Australian code. And then for us, we will include the static load cases and the construction stages load cases. And then for the bridge type, let's use the roadway bridge type. And then there are two types of load factor. One that reduces safety, the other one increases safety for the bridge. So just and then if your combination or the moving load needs to have fatigue, or if the moving load that you have applied on your model is a fatigue load, can define this as such. So since we don't have fatigue load combination, let's just on OK. And then you can see here the load combinations that are applicable for our model. So these load combinations should be copied into the concrete design. So when we go to the concrete design tab, you can see here that the load or strength are added already. Here either stress, strength load combination or service load combination. This one. And here are some of the results that are applicable or that can be applied to our model. So first one is reaction. So say for example, for the first load combination and for the values. So you can also choose if you want to see only the minimum or the maximum values of your action. So here the minimum and maximum values. And then deformation, you can also see the deformation contour. Deformation due to one. You can also change the scale of the displacement contour if you want. And then for the beam diagrams, or you can see it here. So here are types of beam diagram. So below. And you can also see the loads moving for the moving loads that will produce either minimum or maximum in this particular key element for this particular case. So if you see the maximum, the critical moving load trace gives you the load conditions that will produce the maximum of this of Fx, Fc, and Mx, My, or Nz. Either of these components can choose if you want to get a maximum value of those due to element. So for example, if you want to see maximum moment about y, that will be about element 1 or 5 click on apply. And then as you can see, this will be condition that is the maximum moment on this element. So you can apply static load in your by clicking write min max load file. Then you can check if you want to add centrifugal force and then additional longitudinal force for your model. Then click OK. It will then produce a text file, which you can add to your model afterwards. So it's just it we will need to copy and then go to the tools and use the MCL and then copy it and then run it after. So that's what we include this particular load combination with the force and the longitudinal forces. I will not do that since we need to move to the next part. I'll just close this one. You can also see the tendon losses for particular model. So click on tendon graph, then you want to see, then this will tendon loss graph for span 1 first tendon on stage 1 to 5. And see other tendons. Then you can see it as table form. So all of this data he's seen as a table form in the results table tab. So simple tendon, if you want to see that tendons, so results. So you can choose whichever tendon you want to inspect, either in span 1, span 3. These would be the that will be available. So you have the instantaneous losses and the relaxation loss and the long-term effects. So hit by stress or by forces, whichever is efficient for you. Let's close this window. Then to the second part. Using the PSC tab for the design, let's choose first the code that we use. So we will see AS100 and then define the numbers. So first would be the size, maximum number aggregate, and the maximum is control check. So these options are output or the results we see after. So these are the things included in the final report of the PSC design. So need to check it all. And the PSC material. We have two material for complete design, 50 and then C40 to define both of that. For river selection, it's under ESC and choose 100L. And for the slab, use AS17 and river section is also under AS. We have 100, if I C40, 50, river selection is from AS17 as well, real and the sub-river. I need to define this as well as for the river selection again. See what the grade of the mill and the sub-river to define. So then for the design and output design position, you need to select the elements which you want to have a design out. So you want design for example this mhm, let's activate only this part and then say for example we'll be designing the first girders. Click on so all of these girders will have a design output and then for the output position just example try this will have a report in Excel for us who the analysis or the design faster. I'll just only tell them let's add three more. The class. So here is the specification for ES. So the members are protected by damp-proof membrane in non-aggressive soil and for for you sure classification in soils. So you have A1, B2, one C2, and then you. So if you haven't defined this, it will automatically have an exposure of A. So let us now perform the design. Now that the design part of the C has been completed, we can see the result table. So we have those for lecture. So you here if your member not pass the here. And combine shear and torsion strength. You can also see the values in a diagram form. For example, if you want to see all load combinations and with and if you want to check about yeah, so here's a diagram for the for lecture about why. And this is here. So you can please the diagram for that we assign design option 2. And like the torsion. You can also safety factor, say for example 0.75 or the your is that pass the 0.75 criteria line. The Excel report, the calculation design based on AS5105 in the Excel report. Just click on it. And then it generates the report as such. So members that we output for into we have member number 1K. See here the code that is used, the second properties, the materials, then the institution, the longitudinal steel reinforcement that we input using the section manager. The course is due to effective pre-stress. Then here's the flexure design for this section. Flex distance, computation, and then the results. They're designed for this one. And for the shear enforcement design as torsional design. So copy of sheet for you to uh, the data that was extracted automatically using the PSC design of AS51 for the super bridge modeling analysis and design as per 5100.5. Thank you very much for listening to we hope that you continue our webinars. Don't forget to look for the follow-up emails after the thank you very much. Please keep. Bye. If you have any questions, just email us at phquery@midasit.com.
Maganda po sa inyo lahat. Today, we will be doing a brief overview and introduction of the Midas Productivity Support Program. So before we proceed with my actual presentation, let me just introduce myself. I'm Michael John Tungkod. I am currently the Midas Philippines account manager for the building program, which is the Midas Gym. In your screen right now are my contact information, my number, and also my business email address. So let's now proceed with the actual content of this presentation, which is the Midas Productivity Support Program. First, we'll be discussing about the definition of the Midas PSF program, its purpose, benefits, and also who are the quality applicant for this said program. We will be discussing about the process of application, then continue support these will be getting once they push through with the support fund program. So first, of course, the question would be, what does PSF program? Actually, this is the from Midas IT Korea and Midas IT Philippines. The PSF stands for Productivity Support Program or Support Fund. It also it is an initiative that aims to continue the flow of productivity and promote a better quality of work in this trying time. So technically, we acknowledge that during this time, and even before this time, a lot of engineers has been wanting to get their Midas program, and this strike made it more difficult for most of the engineers to get their own Midas Gen program. That's why Midas have decided released an emergency fund almost of more 3 billion pesos, which will be utilized on all the programs that will be built during this program, during this support fund program. Meaning, for example, you are to buy a Midas Gen license, instead of paying 100%, Midas will be evaluating your application, and then part of the 100%, say 45%, 30%, depending on the approval, will pay for the Midas Korea. So technically, you will be get a great number of discount through this application or through this support fund program. So what is the purpose of this productivity support fund program? Of course, the main reason we are doing this is together we can move forward. Midas has found with the idea that we are family. Our heart goes to everyone affected by any trying time that tests our limit. During the Alp volcano eruption this year, to this very challenge that we are facing, which is the COVID-19 pandemic, Midas is always there, not just to assist, but also to make sure that no one left behind while we all move forward. Most of our user, I think they could notice that even during the time that everyone is in lockdown here in Manila, we have still tried to provide support. Magandang umaga po sa inyong lahat. Today, we will be doing a brief overview and introduction of the Midas Productivity Support Fund program. So before we proceed with my actual presentation, let me just introduce myself. I am Michael John Tungkol. I am currently the Midas IT Philippines account manager for building program, which is the Midas Gym. In your screen right now are my contact information, my mobile number, and also my business email address. So let's now proceed with the actual content of this presentation, which is the Midas Productivity Support Fund program. First, we'll be discussing about the definition of the Midas PSF program, its purpose, benefits, and also who are the qualified applicant for this said program. And then also we will be discussing about the process of application, and then the continuous support these the applicants will be getting once they push through with the support fund program. So first, of course, the question would be, what is Midas PSF program? Actually, this is an initiative from Midas IT Korea and Midas IT Philippines. The PSF stands for Productivity Support Program or Support Fund. And then it also aims to it is an initiative that aims to continue the flow of productivity and promote a better quality of work in this trying time. So technically, we acknowledge that during this time, a lot of engineers, I mean, even before this time, a lot of engineers has been wanting to get their Midas program, and then this trying time has made it more difficult for most of the engineers to get their own Midas Gen program. That's why Midas have decided to release an emergency fund of about 3 million pesos, which will be used to subsidize all the programs that will be bought during this program, during this support fund program. Meaning, for example, you are to buy a Midas Gen license. Instead of paying 100%, Midas will be evaluating your application, and then part of the 100%, let's say 40%, 45%, 30%, depending on the approved subsidy, will be paid for the Midas IT Korea. So technically, you will be getting a great number of discount through this application or through this support fund program. So what is the purpose of this productivity support fund program? Of course, the main reason we are doing this is together we can move forward. Midas is founded with the idea that we are a family. Our heart goes to everyone affected by any trying time that tests our limit. During the Taal volcano eruption this year, to this very challenge that we are facing, which is the COVID-19 pandemic, Midas has always been there not just to assist, but also to make sure that no one is left behind while we all move forward. Most of our user, I think they could notice that even during the time that everyone is in lockdown here in Manila, we have still tried to provide support to all our users, online, offline, and then also we try to continuously do our trainings via webinar. Even if we have limited resources, we cannot meet in person, we try to provide support, the unparalleled support that we have been providing to all our users before, to still provide it during the lockdown or the quarantine period. So we were once, and during the Taal volcano, we also have an initiative to provide support to the affected families in Batangas. And also this time, during this pandemic, we also would like to provide support to our industry, to the engineering industry, by providing this productivity support fund program. So, what are the benefits of the Midas PSF program? The first benefit would be an extraordinary discount offer. As I have mentioned, upon submitting your application, the Midas Subsidy Evaluation Board would be analyzing or evaluating your application, and you could be given up to maximum funding support level up to 70%. So the pricing starts, and you can pay your program as low as 6,000 pesos per month. And then also the second benefit would be the free customized learning, private scheduled learning session, and also group learning session with our experienced Filipino technical engineers will be provided to all new users. So this is a benefit that our existing users has already been experiencing. Kasi even before, we have been doing this private scheduled learning session, but this time we are of course leaning towards doing in a more virtual learning program. So, and also the good thing is that you will be talking with an actual experienced Filipino technical engineers who has been using the program for quite a while now, and even used it during their their tenure as a structural engineers in their former companies. And then the third benefit would be giving the applicants or the approved applicants a 6 month installment payment. So they have the option to pay the program with an extraordinary discount offer within 6 months, and then they can pay it through credit card. So, your next question would probably be, Sir, paano ko malalaman if I can apply? So first, of course, the first qualification is this is open for all small, medium enterprise and freelance engineers. And then also for engineering firms that are open since 2015, they have to submit their business permit that will be reviewed by the Midas evaluation subsidy evaluation board. And then also sole private owned firm, freelance, and then even those who are interested in opening up their own firm or in doing private work as a structural engineers are also welcome to attend. SMEs, small medium enterprises, which with three engineers and below can still apply, and even Midas users can continuously apply for this program for their additional licenses. So ang magiging tanong naman na susunod is, Sir, paano yung process of application? Is it hard? Will there be a very strict application process? Actually, hindi we don't need to be worried about the whole application process. First, you have to submit the your application online. We have sent you the link for the application and then for the overview also of the Midas Support Fund program. And then after submitting your application online, um, our the account managers from Midas, either Mr. Daniel John or Mr. Vito Lee will be in touch with you to explain to you further what the whole program will entail, and also will be sending you an NDA form or non-disclosure agreement form that we will require you to sign and send that will be sent back to us with a copy of your PRC ID. Please be reminded that the offer that will be made or given to you are private offers or offers that are provided to you only. So these are special offers made, and the confidentiality of these offers are our responsibility. So that's why um we would like to make sure the confidentiality of the offers through an NDA form. And then after submitting the NDA form, the MIDAS Subsidy Evaluation Board will be analyzing your application with your given information and the history with Midas. After the deliberation, we will be an offer will be sent to you, will be made and be sent to you with up to 70% discount. But again, the confidentiality of the getting the offer. If you would like to secure the offer, you could send us a signed quotation, a copy of the signed quotation, and then also wait for our admin officer to contact you for the issuance of the banking or card information for the billing. So after securing the whole offer, what will happen next? Of course, this is the time that we can work together. After finalizing the secured offer, license will be issued immediately by our team so the applicant can start working. Technical support and online support through other platforms like GTC or the Global Technical Center will also be available for all engineers. We'll be sending different types of PDF files. We'll be doing series of webinars for everyone to attend para they can learn the program. One of the concerns that you might have if you are new to the Midas family is that how will I learn the program? First, if you ask around people, engineers will tell you, even those who are already known structural engineers will tell you that the program is very easy to use. All the things that you need within in doing the projects, almost everything's almost there from modeling up to the design up to the results generation. The wide variety of formats is available, and also the technical support and after sales support is very good. And then we start working together, as I have said. Before I finish before I finish doing my presentation, I'd like to tell that Midas CAD has been launched online and it's free for everyone who's interested as of the moment. You may visit our page Midas Philippines on Facebook to see on how to look over on how you can download the free version of this. Once again, this is Michael John Tungkol, and if you have any more questions, you can message me on Facebook, Michael Tungkol, or you can send me an email, philippines@midasit.com, or send me a text message through 0917-145-5583. I hope that we made everything clear about the PSF program or Productivity Support Fund program, and you take advantage of this very rare offer or chance to get your own Midas license in a very flexible term. And lastly, I hope that everyone will be safe. Thank you.